great honor to welcome you to our session, Electric Mobility, the Battle for Electric Car Supremacy. My name is Ricardo Bovo, and here we will guide you through this session. Now, I would like to present you our first Professor Schweitzer. He studied chemistry at the University of Heinsberg, Germany in 1998 to 2002, graduated in chemistry in 2002. He started his PhD thesis in the field of electrochemistry in the work group of Professor Heiner at the University of Heinsberg, Germany at the end of 2004. Joined EVA in Munich. In January 27, he joined HEV Department of Continental AG Berlin. Since then, he is head of this research institute. The primary field of his group are energy storage systems for automotive applications and automotive safety of electric vehicles. His work group of 12 co-workers is working on 8 industry and government-financed research projects in the field of automotive energy storage system. He also director of study programs in the field of electric engineering and electric mobility, author of several research, more than 20 research papers, and he holds more than 10 patents. He is a member of IEEE, VDE, and VHP. So join me to welcome Professor Schweitzer for his outstanding presentation today.
Okay, then thank you very much for your kind introduction. And yep, it seems to work. Okay, great. So then I can start with my presentation. We want to give you some aspects of the safety of lithium-ion batteries, a little bit about the current challenges and some solution towards the safety issues of the battery, because battery safety is always a very big issue regarding e-mobility. And of course, people expect that an electric vehicle has at least the same safety level as a conventional vehicle. So what we wanted to talk today is about some standard features which are addressed by the battery management system, the BMS right now, like the protection from the cells from mistreatment. This is standard in all battery systems for hybrid and electric vehicles. Then we'll talk a little bit about high voltage safety, so the protection against electric shock. Because in an electric vehicle, you need a lot of power, and therefore you have rather high voltages to transmit the power with a reasonable amount of current. And then at the end, I want to talk about some hazards which cannot be avoided by the battery management system. So you cannot protect the battery from that hazards, even if you have the worldwide best BMS system available. And also a big topic, which is a big issue here in Germany and as well, maybe an even bigger issue in South America, because the weather there is more humid and you have higher temperatures there. So humidity, which will cause a lot of further errors in the site or further hazards in the battery system, which is a topic which is right now not that addressed as other issues. So at the beginning, I want to start with conventional BMS functions, which protects the battery for mistreatment or incorrect treatment of the cells. So we have a 5 different threads to a battery system and to the cell. So battery cells will behave rather dangerously if you overheat them. You have an inflammable liquid inside the battery, which is an organic carbonate, which can catch fire if you overheat it. You have a very strong reductive agent as the negative electrode and a very strong oxidation agent as the positive electrode in close proximity to each other, just separated by a thin sheet of separator, which is typically some polyethylene polypropylene mixture, and this separates these two very reactive agents from each other. And if the separator melts, they can directly get in touch with each other, directly react chemically with each other. And of course, you have an internal short circuit which may burn down the battery as well. So it's very important to protect a battery and the lithium-ion cell from temperatures above above the normal operational temperature. So this becomes typical. We'll see later which levels get dangerous. As well, operating the battery cell outside its voltage limit is dangerous too. Overcharge and overdischarge is dangerous because then other chemical reactions occur than the desired ones, and so side products can be formed, which may cause a lot of gassing in the battery, may cause internal short circuits and other faults. So it's dangerous to operate the batteries outside the operational limit. So the BMS must ensure that each single cell in the battery system stays safe and stays at the desired level. Then another two hazards which may occur in battery systems if overcurrent occurs. The battery system is designed to deliver a lot of current because you want to have a high performance battery system, and if the battery and the current is released in a non-desired way by a short circuit, you must protect not the battery, but mostly you have to protect the environment from the battery by some kind of overcurrent protection. And the last one, you have to have a high voltage system, and therefore you have to protect the environment and the users and the people using the battery from this high voltage. So you need some kind of isolation, monitoring, and isolation protection. So the safe operation of a battery is managed by monitoring and protecting circuits. Without them, you cannot have a safe operation of a battery. You have to need a lot of supervising circuits still. And this is done by the battery management system, which mostly measures three parameters of the cell. It's the temperature, the voltage, and the current. And they do this for each single cell inside the battery system, because you must make sure that each cell is beyond its operational limit. So for a temperature point of view, typically the safety limit is above 80 degrees Celsius, depending a little bit on the cell design, cell chemistry. You can operate lithium-ion batteries up to 80. Some of them you can operate up to 120 degrees Celsius, unless something dangerous happens. So you should not overheat them. If you want to increase lifetimes, of course, it's not good to operate them at higher temperatures, but from safety point of view, the limit starts in the region between 80 to 120 degrees Celsius. And you have to know this temperature of each single cell exactly, because otherwise we'll have some trouble. The accuracies are not so important. Maybe a range of 5 degrees Celsius is enough to shut down the battery system, because you have a very broad window until a battery reacts. And it takes a lot of time until the battery enters a unsafe state. So it's not just overheating the cell 1 degree above the limit and for 1 minute and it will burn down. It takes some time. So therefore you don't have to react super quick. So a response time of less than 1 second is far enough from a safety point of view regarding temperature. From the voltage point of view, it's strongly dependent from the cell chemistry you use. So if you design a battery system, you must be aware of the specific voltage range of the cells you use, because the lithium-ion cell is not a lithium-ion cell, because you can use different anode and cathode materials there, and so they have different voltage limits. So you have to check for the individual voltage limits of the typical cell or the specific cell you use in your battery system. Typically, you have an overvoltage limit above from the range from 4.2 to 4.3 volts, and a lower voltage range something between 2.5 down to 2 volts. Tolerance and response time here does not need to be super quick here, because it takes its time and you have to overcharge a lot until a battery cell reacts in a nasty way. For overcurrent, it's a little bit different, because a lithium-ion battery system can deliver lots of current. In vehicle application, EV system can deliver maybe 5 to 10,000 amps. So that's a huge current, and they can do a lot of harm in a very short period of time. Therefore, you must shut down the system much quicker than the 1 second mentioned in the other. For the other hazards, here you have to react in this range of milliseconds, or a little bit longer if the current is smaller. Here you have to react rather quick. And by this, for all these measurements, all these parameters are checked continuously with the BMS system. You can see a part of a BMS electronics which we developed 10 years ago at Continental. This was in use in the Daimler Smart 401 series or series product, and this PCB board was designed to measure lots of temperatures and a lot of single cell voltages at the same time. And if there was a hazard, we had a two-pole disconnection of the battery system. So we opened the two main contactors of the battery system to switch down the battery system. So this is very conventional. Everybody knows about these features of the BMS. And is a very interesting part, which is not very often addressed in research and in battery design, are the fuses. And in first hand, a fuse is a very simple device. Everybody thinks it's just a wire which heats up if an overcurrent is flowing to the wire and it breaks. So that's the main operational procedure, very simple. But in the real world, because of this heating up effect, the fuses have a very strong temperature characteristic, which is very important. And very often you add some other materials into the fuse wire to change the characteristic curves of the fuse a little bit. And we investigated this causes aging mechanism inside the fuse wires. So the fuse ages over lifetime and changes its characteristics over lifetime. So we have good chance because it changes in a way that it blows at lower currents, which is nice from a safety point of view. But from a reliability point of view, it's bad because even in normal operation, a fuse can blow there. And we investigated this and found out you can see a electroscopic picture of a fuse wire. You have inside copper, and the copper is coated with tin. And we observe that the copper is diffusing into the tin and forming some new tin copper species like Cu7SN3. And this changes the conductivity of the copper, because here you can see some copper voids because the copper is diffusing into the tin, and here copper is missing, and the resistance of the fuse wire is increasing and therefore generating more heat and speeding up this diffusion process. So we enter an aging mechanism of the fuse wires if you operate it in a vehicle application, which is a very important part for designing a proper fuse. We're not very often addressed correctly in current battery systems design, and therefore there are some failures in the field of aging fuses, and we are observing such features. Right now we have a long lifetime project for analyzing this. Another very important safety part or safety feature of a battery system are the main contactors, which are used to shut down the battery system if any fault happens. And therefore it's very important that the battery contactors are always operational. And if you use them, sometimes you generate electric arcs inside the contactors. You can see the two connections, and here you have an internal copper plate connecting the two connections, closing the contactor. And an electric arc is formed inside here, which every time you open and close the contactor under load, and this causes some aging. And if this is not addressed and monitored in the BMS system, the contactor may fail if you need it during another hazard, and therefore the battery system may enter unsafe state. So for having a safe battery system, monitoring the main contactors, having an aging model for the main contactors is also crucial for the safety of the battery system. Because if a battery protects itself with the contactors are, on my behalf, the most important safety devices inside in such a battery system. Yeah, now we go to another topic which is very often addressed in the battery systems, are the high voltage safety, because typical vehicle battery systems run in a range from 400 to 800 volts DC, which is quite dangerous. It's a little bit above the voltage of the mains, and therefore it's dangerous. But to make sure that the battery system is safe even at a vehicle crash, there are some safety features added into the battery system. We have an isolated ground system, so it's safe for the high voltage system to touch one of the two poles because there's no ground connection, there's no electric circuit closed if you just connect touch to one of the one of the battery poles. So it's safe to do this if there is no other hazard. So I don't recommend doing this, because if there's some other fault there, you can die. So you should not risk it. But in theory, it will. You don't close the circuit. It's not dangerous.
Okay.
It gets dangerous.
Professor, just to remind you, have 2 more minutes, please.
Okay, then I'll speed up. Then, so therefore, you have to do this. So therefore, it's a very important, and that's a very good safety feature for a vehicle crash too. So if you have a vehicle crash, you can think about 3 different scenarios. One scenario is that the battery housing touches one of the battery pole if the battery system is deformed. So there is still a safe state because no circuit is closed. It can be touched, nothing happens. If both battery poles are destroyed or connected with the vehicle housing, then you have a short circuit. The fuse will blow, still a safe state. Maybe the battery system catch fire in this case if this happens, because if the fuse fails and then there may be overheating there. And it's a very unlikely event that a battery system is teared apart into 2 different parts touching both poles. It's very unlikely because all the battery system is covered with conductive material like the vehicle chassis, and it's still safe to touch. So that's very, this then maybe in theory is possible, but this never happens. And the last slide. So there are some hazards which can occur, which are not avoidable by the BMS. And this is an internal short inside the battery system. Some years ago, we observed this in a cell we had in our university. Here you can see the separator, here the battery cell housing, and then there was a short circuit between 2 electrodes because of failure of the separator. And this can have different reasons. There can be some foreign matter inside a battery cell caused by production or by battery operation. There can
Professor, I ask you to please conclude. You have 30 seconds.
Yep, so we'll conclude this. There can be some faults in separator and some dendrites growing inside it. And therefore it's very necessary to monitor this by production and sometimes after you're doing battery operation to avoid this failure. Because of this, the battery system cannot protect itself because it has any reaction possibilities to enter a safe state. So this is a short overview about some hazards we have in the battery system which can occur, and there are some countermeasures against it, but it's not possible to protect against all possible errors we can think about. And therefore it's a part of our research to address such issues and to add some additional safety features to the battery system, even if such failures occur, to protect the user from it. So thank you very much for your attention.
Yes, Professor, it's a very interesting point because in the EV world, the battery is very crucial for the car. So in case of a collision, so and the BMS damages, but not the battery, what happens with the car?
So if you have just a failure of the BMS.
Yes. So BMS is like the brain of the car.
And so the BMS itself always tries to shut down the battery system. And only if everything is super perfect, it will switch on the battery system by the main contactors. So therefore, some kind of BMS, you consider it consider as a bad guy, always trying to find a solution to shut down the battery system. And
then if you think about security, so let's see, we see people trying to trap iPhones, Android phones. So what happens if someone tries to trap the BMS to make battery, let's say, lasts longer or add some kilometers? Is it possible to let's say, to trap into the BMS?
Yep, unfortunately, this is possible. And some people do this, for example, by broadening the voltage limits to take out more energy out of the battery, or reducing temperature limits or increasing temperature limits to take more power out of the battery. This is be done. And we're developing some solutions in our work group, how to trap these batteries. So we're also hacking battery systems, and we're developing together with Achim Hof, also professor for IT security in our university, an automatic test bench for automatic hacking of batteries in electric vehicles. And then using this, what we learned from this hacking procedures, we will derive some security countermeasures to make sure that nobody can hack batteries and modify these parameters.
Yeah, interesting. And another thing, so the BMS is responsible for make the battery last longer, longevity. So improvements in the BMS software can help improve an existing battery to last more, or the BMS and the battery are let's say, they work together in a car.
This is they closely work together, and I believe that you have a longer lifetime for the lithium-ion batteries, and maybe in comparison to other battery chemistries like nickel metal hydride or something like this, because for lithium-ion battery you must monitor them carefully because of safety, and therefore you collect a lot of data, and you can use this data to prolong the lifetime of the battery. And what I believed in a lot of applications where you use different battery chemistry, the battery cells just die because of not being operated in the right way as it should be. And therefore they don't last as long as they could. So if you would add a very important complex BMS system, for example, to a nickel metal hydride battery, would be able to last much longer than without a good BMS. So you need both. Supervising for safety, and then you get a side effect, a long lifetime.
Yeah, excellent. Thank you very much. And I want to please forgive me and my apologies for your pronunciation, Professor Schweiger and not Schweitzer. Sorry, my Portuguese is not so accurate for German. So Professor Schweiger, thank you very much for sharing your very interesting points about the BMS, the brain of a car, and the battery importance for the electric vehicle. Now I will switch to our next presenter, Professor Patricio Rodolfo Impinici. Professor was born in Buenos Aires, Argentina in 1962, graduated in 1989 in physics at Moscow State University, Lomonosov, Russia, obtaining his master's degree in 1991 in mathematical physics at Moscow State University, Lomonosov, Russia, and his PhD in 1995 in physical chemistry at the Federal University of São Carlos, Brazil. Professor is now in Paraná in Brazil. Welcome, Professor. Since in 1999, he is a senior research scientist at the Institute of Technology for Development, LACTEC in Curitiba, Brazil, and leader of the Institute Research Group on Batteries. Since 2010, he's an assistant professor at Federal University in Paraná State, Electrical Engineer Department. Professor Impinici has experience in chemistry with emphasis on electrochemistry. Currently leads research programs in development of grid energy storage systems for smart grid applications and develops a continuous research on lead-acid batteries, operation and manufacturing, electrochemical impedance, focus on batteries, energy storage systems, and non-conventional energy power source. He directed 15 master degrees and PhD theses in this field, and is the author and co-author of more than 30 scientific publications on batteries. Oof, it's too big. I hope I did not forget anything. Welcome everyone again, Europe, Latin America, and the rest of the world. Professor Patricio, it's all yours.
Thank you very much, Ricardo, for the introduction. Ladies and gentlemen, good afternoon, or good morning, or good evening, depending where are you. And thank you very much for this opportunity to be here discussing the electric cars and the battery problem. My name is Patricio Impinici, and to start my presentation, let me to introduce our institute called LACTEC in few slides. We are more than 600 workers in 100 of them with postgraduate degrees, many some foreigners, like me, I am Argentine. We are a 60 years old art institute, and in the last 20 years, we developed more than 350 long-term R&D projects in our 6 technological units. In these units, we developed our research in areas like energy storage, mainly batteries, and electric mobility, but our people have expertise in other areas too. Thus, we count on a large number of support laboratories where we study different subjects ranging from biological to high voltage ones and issues related to energy storage, mainly batteries. And this is the main topic of my presentation today. Batteries, a central problem to the electric car supremacy. In my presentation, I will try to answer a very common question about which is the best battery technology for electric cars. I will try to show you the present situation regarding these batteries and what we can expect in the next years. First of all, let me explain what I mean when I say that batteries are a central problem. All people agree that batteries became increasingly central to our daily lives. Remember, in the last year Nobel Prize in Chemistry, we can say that batteries are the new star of science because they are a central problem to many different technological areas. For example, if we talk about portability, that means cell phones, laptop computers, we talk about batteries. They never last long enough, at least never as much as we want. If we talk about modern electric grids, we'll see more changes over the next 10 years than in the prior 100 to improve energy quality, smart grids, smart cities, decentralized energy solutions, and so on. And batteries have a central role to be played here too. If you think about another important area of renewable energy sources, you will talk about batteries again, because batteries act as flexible solutions for renewable energy source utilization. And finally, the main topic of my presentation, batteries hold the key to transitioning away from fossil fuel dependence. They are a tier 1 bottleneck for decarbonization of road transport. Let's see the role of batteries in the electric car case. Today, electric cars face the same problem that they faced 120 years ago. The batteries. They are expensive. The cost of batteries has long been a great obstacle to making an electric car affordable for the masses. But this is not the main problem. Batteries don't have enough autonomy. They take a lot of time to be charged, or you will pay with a faster battery degradation. They last not enough time. They suffer with current voltage and temperature operation conditions. Okay, you can ask, what people, I mean engineers, scientists, were doing last 120 years? Well, they were improving battery chemistries, from heavy elements to lighter and more reactive ones, combining elements, first of all applying the trial and error method that allows our engineers, based on their skills in chemistry, physics, and material science, to discover new battery materials at the cost of considerable efforts, expense, and time. Traditionally, it takes over 10 years from initial discovery to commercialization. Even so, it works out quite well for the challenges people faced last century. Thus, today we can see a lot of different kinds of batteries. They come in all shapes and sizes, countless chemistries like lead acid, lithium-ion, and so on. There are so many that a single question arises all the time. Which battery technology is the best choice for electric vehicles? Which one will be the next decade battery? Which one is the best bet for the future? It looks difficult to answer these questions, but actually, in my opinion, these questions were answered from the practical point of view by the market. What I mean, let's take a look at the battery market. today number may be a little different depending on the source and the year, but this relation that I will show still are very similar today. For example, in 2017, about 85% of the global market value correspond to secondary batteries. Considering the energy volume of those 85%, about 75% were provided by lead-acid batteries and about 25% by lithium-ion. But by market values, these two technologies divide the market half and half. And this practically answers our question about technologies. There are many, but only two of them are relevant. Why? Well, there are many reasons. One of them is that these two technologies have other well-established businesses to support any expansion to any new market like electric vehicles and energy storage. Other reason, they have a production infrastructure and high production volumes. This is why if you talk about next decade batteries, you will talk about these two technologies. And when the issue is electric vehicles, of course, lithium-ion batteries have advantages over lead acid. Then I will focus my presentation mainly on lithium-ion batteries, but let's first talk a little about the forecast for lead acid batteries, lead acid technology. In 2018, 72% of the world rechargeable battery capacity was provided by lead-acid batteries, and it will grow in the next decade, but in much slower rate than lithium-ion technology. Advanced lead-acid batteries are expected to gain an intrinsic market share over the next 10 years. They cannot compete for use in electric cars due to their considerable low energy density with lithium-ion. On the other hand, for lithium-ion batteries, it is expected an exponential growth in the next decade. The World Economic Forum in the European Battery Alliance roadmap forecast an astonishing increase of around 14-fold or more, up to 20-fold, depending on the battery cost reduction in the lithium-ion battery demand. Most due to individual passenger cars demand. This is a global tendency for all regions with an estimated growth rate of 25 to 30% annually for the next years. This huge increase in the lithium-ion battery demand expected for the next years will be mainly driven by electric vehicles and grid energy storage solutions, as seen in this table. This situation will put pressure on the battery raw material industries. Today, the main advance in these areas that will cause this increase in the demand for the battery raw materials will, in the next year, we will need an increase of about 25 times to support this, only to 7 to 13% overall demand for new raw materials. This is why it is crucial to improve the recycling of the lithium-ion batteries. Okay, what about technology? What about the technology? About technology, I mean, in the next decade, according to the European Battery Alliance, the global objective of all these, all people that is researching batteries is to achieve 500 watt-hour per kilogram energy density in batteries. Today, the main advance in exciting lithium-ion batteries is the switching to more efficient, as you see here, chemistry like NMC 622 and NMC 811 technologies. And this is now, but for the next generation technologies, it includes next generation NMC, such as batteries with solid state electrolytes, lithium metal anodes with high voltage spinel cathodes, and include post-NMC batteries, such lithium sulfur and lithium air chemistries. And even the not displayed here, post-lithium technologies such as sodium ion, manganese ion, and calcium ion. And as I say, the goal will be the 500 watts-hour per kilogram energy density battery. Here you see the battery 500 program from USA and the Made in China from China and Rising 2 program from Japan, between others. But look at the graph. There are not miracles. Engineers expect only 50% in the battery energy density in the next 10 years, not 2, 3, or 10 times, just 1.5 times in 10 years. And for the period after 2030, there are a lot of challenges to achieve this. But for the period after, okay, I am not looking, okay, I am fine. Okay. After 2030 that we see here, there are a number of potential technologies that may be able to push the boundary beyond the performance limits imposed by the lithium-ion technology. The most promising near-term chemistry is the lithium metal solid state battery, because it is difficult to increase the energy density beyond today's cells using graphite anodes. Lithium metal anodes can deliver almost 10 times the energy capacity of graphite ones. However, lithium metal anodes suffer from the poor cycle life, typically 10 cycles or less compared to the 1,000 cycles needed for the electric vehicle battery. Let's compare this today lithium-ion technology performance with the expected performance of the next technology displayed here. Today, the most promising energy storage, the most promising energy storage technology for automotive application will be the short term, will be the lithium metal solid state. But the use of metal lithium anode in liquid cell still appears very challenging due to the presence of flammable organic electrolytes. The use of non-flammable solid electrolyte is planned to start in 2025 with the all solid state batteries, or ASSB batteries. This lithium metal all solid state battery with inorganic solid electrolyte is considered one of the most promising energy storage technology for automotive applications. But for all that, engineers have many challenges that need to be addressed. That means a lot of research must be done. And for that is necessary a new path for faster development. And this is crucial. This is very important. This traditional research methodology based on trial and error approach is not more acceptable. This is why the European Battery Alliance proposed a new development strategy, a paradigm shift, a collective effort based on self-driving laboratories, genetic algorithms, machine learning models, big data analysis, in few words, a fully autonomous discovery process of battery material and chemistry. It could be the breakthrough needed to develop, needed in development speed, maybe 5 or 10-fold. To achieve the development target for the next decade, electric vehicles, cars, it is necessary to reinvent the way we perform the battery material research today. This can be done by combining this new powerful approach sustained by the fourth industrial revolution, I mean Industry 4.0 and digitalization. Next decade will be the artificial intelligence decade, with the in situ characterization in operandum sensing to transform the way we understand and discover new battery materials and interfaces. It is expected that this new way of research will increase the pace of new discoveries, I mean new kind of longer life, low cost, high performance batteries. Now I am in time. Yes. Okay. And now to finish, a few comments. In the last 30 years, this is my last slide. In the last 30 years, lithium-ion batteries doubled the energy density and the cost dropped by the factor of 15. In terms of battery chemistries, the transition to lithium-ion fourth generation ASSB battery with lithium metal and fifth generation lithium sulfur and lithium air is planned starting from 2025. Overall, it is clear that all battery roadmaps aims to reach the same target of about 500 watts-hour per kilogram battery in the next decade. Okay, in my opinion, we can expect that for the incoming decade, the lithium-ion battery and its improvements will dominate the electric vehicle market for 3 reasons. First, this technology is well established. Second, the very large investment in lithium-ion manufacturing and supply chains constitute a barrier to entry for any alternative technology. Third, alternative technologies are still at a range of lower technology readiness level. None have yet been used in real-life condition in commercial vehicle application. Even after a new technology reaches a level of technological maturity, there will be a considerable delay before it will begin to penetrate the market. This is because extensive testing under real conditions is necessary. There is a precipice between a laboratory test and prototype, between laboratory tested prototype and a fully commercial ready product. Today,
Professor,
yes?
I ask you to please conclude in more 30 seconds.
30 seconds, okay. Today, as it was in the last 20 years, we see a lot of announcements about new and novel battery chemistries, but many of them are miraculous ones, like indestructible batteries that charge in seconds with 10 or 20 times more energy density than today's batteries, and so on. But for any novel and future battery chemistry, and I finish here, be the electric car battery is a challenge as, first, high performance materials are still lacking. Second, engineering concepts have not been developed and tailored for efficient cell production. Third, performance degradation remains an issue. And finally, the cost. Today's price of a state-of-the-art lithium-ion packs is around roughly $120, $150 per kilowatt hour. And the cost for the next year years is expected to decline to well below $100 per kilowatt hour, a cost level that any future battery chemistry must reach to be competitive. Okay, and this is all that I had for today's presentation. Thank you, Ricardo.
Thank you, Patricio. Thank you, Professor. It's a very challenging subject. It is the battery for the electrical vehicles. I am a EV owner in Brazil. I am an entrepreneur. Okay. And I have noticed that the batteries have increased the capacity since 2014 when BMW launched the i3. I had one just to 100 miles lasting. And now if you look into the Tesla, it has 400 miles. I mean, it has a huge improvement. But so give us the possibility to drive longer in countries like Brazil, Argentina, where the infrastructure of EV chargers are not good enough like Europe and US. But I have a question for you about refurbishment. So many people, every time I park my car, everyone that looks into my car with the camera to take a picture asks, well, what do you do when the battery is dead? So batteries for EVs lasts 15, 20 years. But how do you see the refurbishment? So make the existing battery, the existing chemistry lasting longer without the need of changing the car. Because the battery is like the reservoir for gasoline in a ICE car. I mean, you don't change it often.
Okay, I think, Ricardo, that, okay, this is a good question because all people agree that lithium-ion battery has made a tremendous progress in the last years. Yes, and it will be in the next years too. And batteries are considered that achieve the end of life when they lose about 20% of the initial capacity. That means a battery that at the initial moment have 100% of its capacity, when achieve 80% or 70%, they are considered that they need to be replaced. There are a market for that. You see that the second life for these batteries and so on. But I think that this example that you mentioned are not the batteries for the car for the masses. They are expensive cars. For if you want to replace all the car with the internal combustion engines, you will need cheaper batteries that last longer than the cheap batteries that we have now. Then I think that, yes, the battery must last at least 10 years, 15 years, using in very unpredictable condition in many cases. Then
yeah, and thanks for the BMS for that. So the BMS helps
yes,
battery lasting longer. And
yeah,
I'm sorry to interrupt you.
No,
Let's leave this conversation for the end, because I want to ask your friend, Mr. Mariano Jimena, from Argentina now, the Association of Argentina, my friend, our Mr. Patricio, Professor Patricio is Argentinian too. So thank you very much for your outstanding presentation about the batteries, a very crucial part of EVs. And now I welcome Mariano Jimena. I'm sorry he's not a professor, but he's an outstanding professional in the EV world. He is currently president of AAVA, Associación Argentina de Vehículos Elétricos y Alternativos, Argentinian Electric and Alternative Vehicle Association. We are together part of Alamos. I'm from Abrave and he's from AWARE, the Association of Latin America for Sustainable Mobility, since 2019. And he's a businessman and works on industry and mobility. He's a specialist in EV chargers. Good, we need you in Brazil, and their infrastructure. Because of the aforementioned experience, he was in charge of the recharge team in the electric Dakar in 2017. Mariano proposes e-mobility in Argentina and the region because he believes this is a way to be more sustainable and pass on to the new automotive industrial area. Well, please, my guests, welcome to join Mariano Jimena, and it's all yours. Thank you, Mariano.
Thank you, Ricardo. Thanks for the organization. Hello, everyone. Well, here we go. Such as Ricardo says, I am Mariano Jimena, president of AWARE. AWARE is the Electric Vehicle Association from Argentina. The association was founded in 2013 by 23 members, and now we are almost 150 members in the association. The association, all of people who wanted to be part of the association can be, because it's persons are the associate. As Ricardo says, AWARE is member of Alamos. Alamos is the Latin American Sustainable Association. The association was founded in 2018 in Sao Paulo, in Brazil. Here, in the left side of the screen, you see members of AWARE in the National Congress in Argentina during a meeting about e-mobility Congress. And in the right side, you can see the first meeting of Alamos in São Paulo, in Brazil. There is the first president of AWARE, the president of the Colombia Association. He is now the president of Alamos, and the president of the Association of Peru, ADIVE Peru. About the association, we know e-mobility has impact in many sectors. So we can, when we are talking about e-mobility, we have to talk about transport, industry, energy, infrastructure, environment, health, education, economy, and regulation. So that's because it's not easy to think e-mobility as a fast change. It will take time. So about Argentina, the idea of this slide is to show some things about Argentina, some topics about the area, 2.78 square kilometers. The population is estimated in 45 million inhabitants, and the cities are so far from each other. Why I am talking about this? Because the infrastructure chargers, EV chargers, because the country is huge, maybe compared to other countries, maybe countries in Europe. It's so complicated to install all points to reach from one city to other city with one charge for the batteries. About the vehicles market, around the 4% of the industrial PIB correspond to the automotive industry. During the best years, the numbers of sales cars reach around 900,000 units, and about referred to motorcycles, the number reached 450,000 units of motorcycles here in Argentina. And we have a fleet in Buenos Aires city and surroundings around 18,000 of buses. Of course, the buses are not electric buses yet. About EV market, Argentinian EV market, our EV market, it's very, very small. As you can see, we have around 100 between battery electric vehicles and plug hybrid electric vehicles, only around 300 chargers. Of those 300, only less than 30% are public. The rest of them are private. And only 3% are DC chargers. So our fast chargers are very, very small quantity. Of course, those numbers are not enough. So the question is, why Argentina is so behind? If we compare Argentina with other countries, of course, USA, Europe, China, we are so far. If we compare with other countries of the region, South American, Latin American regions, Argentina is so far too. Car prices are very high. The number of models are so scarce. We'll see in the next slide how many models of electric cars we have here in Argentina. Planning the automaker industry is not easy, and Argentina needs, of course, more public policies. We know when public policies are present, the electromobility improve. Here in this slide, some examples of battery electric vehicles and plug hybrid. And here is not one more, the Porsche Taycan. The launch was a few months ago. So we have only 3 cars, electric cars, battery electric vehicles, and 1 plug-in hybrid. Please, if you can pay attention to the prices around Kangoo, 100% electric, it's around 30,000 USD, Nissan Leaf 62,000, and Mercedes-Benz GLC, the price is 85,000 USD. So if you can compare with the prices here in the region, Latin American region, or maybe in Europe or United States, you will see the prices here in Argentina, they are very, very high. So some points to bear in mind. Here in Argentina, we have 12 assembly production automobile cars makers. We need a plan to introduce in the new era here in Argentina, in the new era of automotive industry. And in comparison with other countries in the region, Mexico, Brazil, and Argentina have the biggest industries. And if you see, you can see the numbers of those countries, 3 countries, they are behind in comparison between perhaps if you compare with Chile or Colombia, the numbers are very higher. About policies and regulations. We have some local policies in some cities or provinces, but they are not enough. We need federal laws. So in those days, our government is working on a sustainability mobility law. The idea is to have maybe a law for electric vehicles for the next year, because we need this law to promote electric vehicles here in Argentina. Since 2018, we have a national legislation has included categories L6 and L7. They are for microcars regulation. We have some rules for EV chargers installations based on IEC standards. We are looking more for European standards. But anyway, we have chargers with type 1 or type 2, CHAdeMO, CCS combo 2 and 1, no matter about that. And about e-bikes, we have a regulation and a standard. The name is IRAM 60020. It's for e-bikes with pedal assist, max top speed 25 km/h, and top power, max power, it's 500 watts. About e-buses, our opportunity, yes, we know that all the region needs e-buses. We have to change ICE fleet for electric buses. We can see some numbers. Only in Buenos Aires City, we have 18,000 buses. In Latin America, there are around 100,000 buses. And why we have so many buses? Because we have less subways or maybe trains than other countries. That's why we need e-buses here in Argentina and all the region. About lithium cells and battery packs, we all know between Chile, Argentina, and Bolivia, we have a long extent of resources of lithium. Here in Argentina, there are 3 companies that produce battery packs, no cells, okay? Only battery packs. They imported these cells from other countries and assembled the battery packs here in Argentina. Maybe in the future, with our lithium, Argentina could be a manufacturer of battery cells too. And we think and we know maybe the price of a car around 50%, now maybe 40%, corresponds to the cost of battery cells and battery packs. So we need batteries to improve our EV market. And in order to finish, because of the industrial automotive history, Argentina is a great place to produce EVs, and it is relevant to know that we have manpower to do so. Thank you very much.
Thank you, Mariano. Very interesting. We share some pains. We from Brazil and you from Argentina. And I have some questions for you. So we know that the cost of an EV is very expensive, but at the same time, the use of a car makes it, let's say, more affordable. In Brazil, for instance, the cost per kilometer for an EV is 2 cents of dollar. And if you compare to ICE, gasoline or ethanol that we produce in Brazil, is at least 6 times more. I mean, 10, 12 cents of dollar. So although the cost of the car is heavy and more expensive than an ICE, when you use it massively, 3,000, 4,000 kilometers a month, then the car make the use of it affordable. So have you thought about it? I mean, we have in Brazil 11 models of EVs right now. I mean, we are increasing, and the fleet has been double from last year to this year. I mean, we are still running slow, but we share the same pains about, let's say, infrastructure for charge. I mean, the biggest, I think, pain we have in Brazil, as you have in Argentina, are the super DC chargers. And what we have seen in Brazil, that when we cooperate with the utility company, the utility energy distribution company, they install the DC charger, because we have in Brazil a law that they needed to invest a part of the revenue, 1% of the R&D, as R&D. So when they are installing DC chargers in the highways, so this could be a nice tip for you in Argentina to bring the utility company to see somehow they could install the DC charger and make, let's say, the trip safer and better. I don't know if you agree with that.
Yes, I agree with you. Maybe here in Argentina, now the problem, or our biggest problem, is economy. You compare how many kilometers between ICE or EV car in dollars, in USD, and now the USD for us is very high. So the prices, the car prices are higher too. But if you use a car 50 kilometers or maybe 100 kilometers per day, I have an EV car, and the difference it's so big. Maybe, as you say, 5, 6, or 7 times the price of 1 kilometer in an electric car or combustion engine. About the utilities to install DC fast chargers, that's the idea, because now the price is high too, and we only have 2 models with fast charging. One is the Nissan Leaf, 50 kilowatts of power, and the other one is Porsche Taycan. So the utilities ask themselves, why I'm going to install a DC fast charger if there are a lot of slow to charge in maybe 7 2.4 kilowatts of power, maybe an Kangoo. So we are in the race, maybe so behind. We need more electric cars here in Argentina to improve the infrastructure.
Yeah, interesting. And I see that, I don't know if you are aware, but for my friends in Latin America, that in Brazil, we just started a factory to produce EV batteries in Manaus. And this factory is held by BYD, the Chinese company. So it has been inaugurated 2 months ago, but we see in the future that EV batteries will be a little bit cheaper because they will be manufactured in Brazil and they can be exported to Argentina due to our Mercosur agreement, free trade zone agreement. So I see a better future for us in terms of EVs. And back to the portfolio of cars available in Brazil, we have many cars with DC ports. So just Renault Zoe, it doesn't have the DC outlet, but you have a Bolt, i3, Leaf, Jack, and the Rizzo 5 from Chery. So a lot of other models that could be exported to Argentina as well. Anyway, I have a question here. We can start a little bit a discussion among us because the question is not only for you, Mariano, but maybe for Professor Impinici and for Professor Schweiger. From Marcelo Gribler. I have a question to any of the presenters. I would like to understand better what is cobalt used for in the lithium-ion batteries, and if there are any possible substitutes for it. I have heard that there is a problem with the supply of cobalt because Uganda concentrates the majority of the world reserves. Who would like to answer this to Marcelo?
Okay, I can start and maybe, okay, of course, the cobalt-free batteries are in the way because people is researching, as I show in the presentation. Today you have a NMC 622, that means 60% nickel, 20% cobalt, and 20% manganese. But it was 30%, 30%, and 30%. And in the next years, people is trying to achieve 8% nickel, 10% cobalt, and 10% manganese. And in the future, without cobalt. People is working on that. But the problem is that the nickel have a temperature problems, the stability is more sensible to stability. People is researching, but yes, you are right. Cobalt is a problem. Even you have the battery, the lithium iron phosphate battery, cobalt-free battery, but this battery have a low energy density. Then you are right. People is researching batteries without cobalt because cobalt is a problem. Yeah.
And there's also some other, so the cobalt is used as in the metal oxides, which are used as positive active material, maybe to explain why they use this. And there are also some other alternatives, especially, for example, the manganese oxides, the spinels, which also has some drawbacks, especially regarding lifetime for this material. And there's even some 10 to 15 years ago in the market, there are some cobalt-free alternatives, but they don't have that overall a good performance. So you have every time some drawback regarding energy density as iron phosphate or lifetime with the manganese spinels. So there's not right now not the super perfect solution. And by reducing the cobalt amount in the NMC material you gain, that's the big benefit. You gain some energy density, but of course you pay it with safety. And
yeah, you just commented in the chat that we in Brazil will produce the cells in Manaus.
Ah, great.
Yeah.
It's a great achievement we have made during the pandemic. Anyway, I have another question from Marcio Rodrigo Santos. He put in the chat, maybe the better solution is put more energy and effort in research of better solar panels and electric motors with less consume, putting less responsibility upon the battery itself. Or like a bumper car in amusement park or subway, a way to use external ecological energy from the environment was to recharge the battery while the car is running. So who would you like to be the volunteer for this question? I have some comments on that. I mean, today it's still difficult to put a solar panel in the roof of an EV and let it recharge the battery, because the amount of power you can convert from the sunlight to real electricity is not enough. So it's difficult for a car, maybe for a bus or a truck. But Professor, what is your comment on that?
There's one startup company in Germany doing this, and they're developing a small conventional, small vehicle, not a very big size vehicle, just a normal vehicle. And they include a solar panel into the roof. And then they have done some calculations regarding their vehicle, regarding the weather in Germany. And they claim, I have not checked it, but they claim that in a very good condition, you can generate about 30 kilometers a day on mileage with a solar panel in Germany. And in poor condition, it's about 5 kilometers per day. So it may be a good solution if you have a short driving range or a short mileage per day. For example, a short commuter, maybe commuting 5 to 10 kilometers to work and back home. This will be some add-on energy. Not a complete solution for the whole driving range, but maybe you can add a reasonable percentage of the energy with the solar panel included in the rooftop.
Yeah, very interesting. And you know that for the majority of the audience, that in Brazil, the worst part of Brazil to produce solar energy is, let's say, twice better than the best place in Germany. So in Brazil and South America, we have a privilege of converting the sun into electricity. And if we use it more often than we are using today, I think we can produce a lot of, let's say, ecological energy in Brazil with some producers next to the roads, accumulating energy in the highways for the EVs installed in the highway. So we have this project in Brazil in the college I teach in Facens, but it's a very, very interesting topic. Mariano, Patricio would like to comment?
Yes,
Okay,
something.
I have, yeah, please.
Sorry?
Then I have another
Yes,
question.
Many times people ask, why do you want an electric vehicle if your energy comes from fossil, okay, from fuel? Because nothing is perfect, and first we need to have the technology, the EV cars, to plug to the grid, no matter where come from the energy. And in the ideal, when the energy comes 100% from renewable energy, it will be great. In this moment, in Argentina, only produce around 10% of the energy from renewable energy, solar and wind. Maybe in the future we can reach 50% or more, but if you use an electric car, you will use less energy than an ICE car.
Okay.
Yes, but if we switch to Brazil, I mean, Brazil, the majority, 98% of our energy producing is from hydroelectric. So we are a clean energy producer, and we have an agreement, Paraguay, Brazil, and Argentina, that is Itaipu, in the triple border of Foz do Iguaçu. So we, at least in South America, we are doing great in terms of renewable energy, and our matrix for production is not dirty, it's clean. So EVs, I think, is a solution for countries when you have a clean matrix of producing. Sorry, Professor Patricio
No,
Schweiger.
sorry. I was thinking still about the Marcio question, about harvesting energy from the environment. This is very interesting because another problem that we have with high energy density batteries is that when you want higher and higher and higher density batteries, but this will be always a problem with the safety. Then, in fact, it is a solution if you could use low density energy battery, but that you recharge all the time using the environment. The concept is very interesting. Not today, because I am not sure that today this is possible, but in the future may be a solution, because increase the energy density without limits, this is not a solution. Yeah.
Ricardo?
Yes?
Sorry,
Yeah.
I would like to ask to Patricio or Professor Schweiger about what do you think about battery swap? To change batteries.
In addition to your question, I have a question from Murilo Medeiros. He said, would you have some perspectives on battery thermal management system, BTMS, for the next years? I mean, such as BTMS based on flow boiling, heat pipes, etc. So I think it joins Mariano's point.
So maybe I will answer on these two questions. So for swapping the battery, I believe it's a very complex task doing this and for the standardization between different vehicles and even between different vehicle manufacturers. And therefore, I believe it's too complicated that you get a standardized version between this. Maybe it's a good idea because having a small battery, which you can swap easily, but I believe this will not happen because it's very complex integrating a very big thing into a vehicle. And the biggest discussion you have within the vehicle, on the biggest fights you have within a vehicle manufacturers are the discussions regarding installation space. And if you have a rather big one, as a battery, which is enormous, I don't believe it's possible to harmonize it between different vehicle manufacturers. This would be a nightmare harmonizing this. And even what I believe it won't be happen in the near future is because you have a big changes and the engineers learn a lot with developing a battery system and how to make a perfect battery system. There's still a lot of engineering work going on. And if you look in a battery system, which is being developed right now, compare them with then developed 5 years ago, compare them developed 10 years ago, they're completely different systems. And so if you harmonize it right now, even if you can manage it harmonizing between vehicle manufacturers, you will freeze at a state of technology which is not perfect yet. So especially for the sake of further development, it would be good to have an open system and modify it maybe the next 5 to 10 years and even further in the future, because you have other cell chemistries. They will have a strong impact on battery system design too. So therefore, it's because of progress of technology, it would not be good to harmonize it. Maybe in 50 years it may make sense, but I believe it doesn't. It won't be necessary at the time because you will have batteries with enough mileage in it, and you will have battery systems which will last as long as vehicle lifetime. So that's common for this. And for the other ones, for advancement in the cooling systems and the BMS systems. So regarding for heat pipes, don't believe that they will enter the battery systems because for operation of a heat pipe, you need a big temperature difference between the cell you cool and the surrounding. And the big problem here in developing cooling battery systems is that the battery system must stay at a low temperature. And the temperature is similar like the ambient temperature. Maybe in Germany you have a temperature difference which is positive, so you can transfer heat outside from the battery to the surrounding. But even in a German summer, you don't have a positive temperature difference, so you can transport heat, so you need an active cooling element there. In Brazil, it's even worse, because if you have good luck, then the battery is hotter than the surrounding, you can transport heat out of the battery. So that's the big problem in cooling the battery system, is the heat gradient and the sign of the heat gradient. And therefore, maybe the heat pipe won't be a good solution, but I believe that some good air conditioning system and heat pump system included in the battery will do the job in both countries, even in a rather cold country as in Germany.
Yeah, we face same problems, but in different edges. In Germany, the lower temperatures, and in Brazil, the high temperatures. I had a friend that he lives in Germany, and he told me once, we still can go to the beach in Germany. You should dress a jacket to dive into the water, but we still have beaches. So there's an important question here from Roy Gunnar. He said, is the private installation of photovoltaic panels in Brazil and Argentina financially attractive? Let me answer from Brazil perspective. Yes, it is. In Brazil today, I personally have a photovoltaic system in my house in Brazil, so I don't pay energy. I charge my car with that. And it costs us around $7,000, the full system, per 1,000 kilowatt hour per month. So this is the average price in Brazil. So everyone, in Brazil, we don't have a mass incentive from the government, but for sure, from Brazil perspective, we have a lot of sun and it's very affordable, and I encourage everyone to start investing and produce your own energy. At least you save a lot of money in the future. But I pass to my friend Mariano and maybe Professor Patricio, your point of view from Argentina.
I'm not a specialist in solar energy or panels, but maybe the problem now is because the cost of the installation in dollars is too high for Argentina, and the prices of the cost of energy is low. Maybe in the future will be again to be okay to put more solar panels in private houses. Patricio, what do you think?
You were on mute, Patricio.
Yeah.
Okay, I am mute. No, I don't have any comment about that. Yes.
Yeah. So, now we addressed many of the questions from the public. Mariano, Professor Schweiger, and Professor Patricio, do you have some point of view to address from us? Some questions about you would like to hear from the presenters? If you don't, I have some.
No, Ricardo, I would like to remark, to highlight about our association Alamos. That it's very important for us in Latin America to work together. Maybe the experience of Brazil or Chile or República Dominicana, it's good for Argentina, and we have to share information and maybe to work on some common regulations and to promote similar technology, because I think it will be easier for us to work together in the region. And of course, we need the information and the technology from Europe, from Germany, because without this technology, it's impossible. But it's very important what are we doing with Alamos, and I invite other countries to join us in Alamos.
Thank you.
Okay. Professor, 1 minute for you to make your final considerations, and then Professor Patricio.
Okay, so thank you very much for this very interesting discussion and the opportunity to share our ideas. And it would be a very pleasure for us to do some research collaborations in the near future with Brazil and Argentina as well. This would be very helpful for us for furthering the future collaboration. And I'm hoping very well that the governments will fund such endeavors. Because right now in the past we had a lot of the difficulties finding money for doing not only exchange but for doing research together, and this would be very happy if we find some funding schemes for doing this.
Professor Patricio.
Thank you again. Thank you very much for this opportunity to be here. And I want to say that our institute and university is open to partnerships, because we understand that next decade will be the decade of the batteries, and we want to be part of that. Then we are open to partnership, to work, to research, as we have with the Professor Schweigers and other institutes. Thank you for this opportunity, and it was a pleasure to be here.
Yeah. So we have already come to the end. Thank you very much, everyone, for your outstanding presentation, for the public, for the questions. It was quite a fruitful exchange here. If I couldn't address all of your questions right now for the audience, you are free to contact our speakers via the bilateral chat for further 15 minutes. Just go to the speaker with your mouse, select the option More, and you will find the option Chat. Then you can contact the speaker directly, and he'll try to answer your questions one by one. Dear guests, it was a pleasure to guide you through today's session. If you would like to recommend it to friends and colleagues, you will find the recorded sessions on the website of AWARE website. Just have a look at aware.thi.de. There you will also find our contacts, and if you are interested in getting closer contact with our AWARE Center, feel free to go. Last but not the least, before we officially close our session now, I remember you that more sessions are coming in the next few minutes. So please take a look on the next sessions. Please help us improve our event and give your evaluation in our short poll that we will see right before we end. So before I say goodbye to you, please evaluate our session so we can get better and improve and make it better for the next session. Goodbye. Thank you very much for your patience, for your audience and your interest. I congratulate Mr. Mariano, Professor Schweiger, and now I didn't mistake, and Professor Patricio. Thank you very much for joining us this afternoon in Brazil and the rest of the world. And I let you with the public, with the organization for the next event. Don't lose today and tomorrow. Thank you very much.